The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Okay, thanks a lot, HS, and thank you, all of you that had the patience to be at almost 10 at night on Sunday listening to all these natural disasters. But I think it's very important, and I'm not going, very briefly, I'm going to explain what we did here in this building. This is the photograph of one of the tallest buildings in Mexico City. And the thing is that this belongs to a bank, BBVA Bank. It's a Spanish owner that actually bought the largest bank in Mexico, and I used to be their consultant. So when this happened, they used to have a headquarters of only 6 stories. And suddenly they, that was a great idea for them to put a 50-story building. When this happened, and I was the peer review for this building, the owner came to me and said, Roberto, what should I do when there is an earthquake? And I didn't know if I will laugh at his question or I should be serious, because when he explained that, I say, and he immediately said, well, what should I do during an earthquake? I say, well, do you know how to pray? Because, there is no way to evacuate this building. So he said next, well, what do I have to do then, And I say, well, that's very simple. Just why don't we instrument the building? We know that the chances of a collapse are very, very small, because we did the peer review, we at least had the feeling of that building. But I say, we will not know if there is a damage until, we check it or we instrument it. So they say, well, and it's a Spanish guys which doesn't experience before an earthquake. So it was very easy to convince to instrument it. So he said, well, I will do that. So what do I have to do? I say, well, first of all, we have to do a nonlinear analysis, a nonlinear model, and also to put some instruments. So it was funny because my advisor was Mette Sousen. And I say Mette, because when I did my PhD at Illinois, I was more in the analytical part. And I didn't have any experience of instrumentation. And I knew all my colleagues were instrumented, the small models at the Newmark's lab. So I say, Mette, how many instruments should I put in that building? Say, well, as a researcher point of view, I will put he said 200 instruments in all the building. But I say, well, I think if you want to be right, just put 8. So we put it 8. And if you see the location of the building, the location of the building is just in the trench that Sergio just showed. So it's right there. But it's very tall, so we are very far from the 1 second. So, we didn't expect damage, but we didn't know about non-structural damage, even though we calibrated the model with the instrumentation, with some measurements that we had previously, that they were very, very low magnitude earthquakes. And so at least we have the chance of extrapolate some of these measurements and to see, that it will be very, very difficult to get some damage. And actually, you know, I saw, I don't know if you have had chance to see that this is not a concrete building. And it looks like a steel building, but it's really a composite building because the main columns, you know, the 6 main columns are tubes and are infilled with concrete. So basically, you know, the behavior is more a concrete building. There is no core, so everything goes into the facade. All the structure concentrates in the facade. It's an eccentric brace. So all the hinges will form, it's like, well, it's designed so that all the hinges will form in this part that we call fuses. And it was funny, after the earthquake, you know, the guys that they were, some of them in Spain, they say, how many hinges were formed? I say, how many hinges? Yes, you have to look carefully at the hinges. I say, I don't think that they formed any of them. So I went to the building after like 3 days because they wanted me to check right away, but I had the information almost right away. Actually, in the September 7, in the first earthquake, you know, we measure, and in less than 10 minutes, we got the information, the accelerations, the maximum acceleration in each point, and actually the Fourier analysis, and also we got the periods of the building, and we saw that it was no damage at all. So the instruments were located at the basement, at the ground level. Another was in level 23, then 35, 36, and 3 at the top to see the torsional and the translational mode. So the model, I will say, this is what we call the design earthquake, the design spectra, the design acceleration that we use for the record. And you will see here the formation of the joints, but this was not what it experienced. It was kind of saying, you know, this will be the design. If there is a design, it will form the hinges that I'm going to show you, but all of them are in the operational portion, so there was no permanent displacement or damage here. And let me run this if I can. Oh boy. Okay. So there is no hinges, and then suddenly almost all is formed. So now, in the first earthquake that occurred in September 7, as Sergio described, it was, you know, for Mexico City, it was very minor earthquake. You know, we basically feel it, you know, very, very minor. And the sensor number 8, it's at the ground level, and you can see the maximum acceleration in the order of 10 gals, more or less. If we see the displacement, the total displacement was like less than 5 inches, almost 5, in the order of 5 inches. If you see the drifts, the maximum was 0.3086. So it's very, very small. Now, for the September 19, you could see that it was almost 6 times, or 5, 6 times here, the acceleration. And the displacement was, I will say less than 8 inches. Which was a little surprise that, you know, the big difference in acceleration, at least to me, probably for you, you know, some that are very familiar will be easy to explain, but for me, you know, I expected like more difference in the total displacement. And drift, the maximum drift, is 0.00155. So it's very small to have a non-structural damage as well. So, and it was the case. Nothing happened to the building, and it was fully operational. And immediately, you know, I communicated that was no damage. The problem that we had in Mexico is after this September 19 earthquake, the communication was lost, but not as bad as in Puerto Rico. You know, we had like probably 15 to 20 minutes of communication lost, so we recovered very, very quickly in that respect. And with that experience, you know, the client was so happy that now, and that's a good news for ACI, because now we are going to instrument this building, which is a 40-story building, but 100% concrete building. So we hope that within like 6 months, we will be able to instrument this and to prepare the analytical model so that we will be prepared. And I hope that Sergio, you know, will be wrong, but yes, we are expecting the big one, because this was not the big one, even though it had, we had some damage. But really, you know, we expect one from the coast, you know, from the Guerrero, or what we call Brecha de Guerrero, or from the Guerrero fault. And I think that's what we will expect, to have more acceleration and hopefully not so many problems that we had right now. So with that, I would want to thank you.